Today, we're going to do something pretty cool. We're going to listen to the heartbeat of a machine. We're breaking down a really practical IoT project that lets you keep an eye on and even control industrial motors from literally anywhere in the world. And trust me, it's a little peek into a much, much bigger industrial revolution. Just think about it for a second. Imagine a vital piece of machinery, maybe on the other side of the country, maybe on the other side of the planet. What if you could see exactly how it's running right now, just by glancing at your phone? Well, that's not some sci-fi movie plot. It's the power we're unpacking today.
So, to really get why this is such a big deal, we need to talk about the unsung heroes of the industrial world, electric motors.
Seriously? From the conveyor belt in a factory to the pump at a water treatment plant, these things are everywhere. They are the absolute workhorses, tirelessly turning electricity into the motion that drives, well, almost everything. They're literally what keeps our modern world humming along.
And that, right there, is the million-dollar question. When a motor fails out of the blue, production doesn't just slow down, it grinds to a halt. We're talking missed deadlines, skyrocketing costs, a total nightmare. The whole game is about seeing that failure coming and stopping it before it ever happens. So, how does it all work? Let's pop the hood and break down the anatomy of this IoT monitoring system, piece by piece.
You know, the best way to wrap your head around this whole setup is to think of it like we're giving the motor its very own nervous system. It's got senses, a brain, a way to communicate, and even muscles to take action. Okay, first up, we give it senses. An IR sensor acts like its eyes, watching the motor's shaft to measure its speed. An LM35 sensor feels the motor's body, kind of like a thermometer to check if it's running a fever. And an AC712 sensor measures the current, which basically tells us how hard the motor is working, how much of a load it's under. All that sensory data flows to one place, the brain. And in this system, the brain is an Arduino Nano. It's the central hub that takes all these different signals, speed, temp, current, and makes sense of it all.
But hey, a brain is pretty useless if it can't talk to anyone, right? That's where a Wi-Fi module comes in. It takes all that processed data from the Arduino and zips it over to an online server. This little piece is what actually puts the internet in the Internet of Things, making all that motor data available from anywhere. And last but not least, we give it muscle. A relay switch is basically a remote-controlled light switch. It listens for commands from the app, letting us physically turn the motor on or off without ever laying a finger on it. This is where data gets turned into direct action. So, just to recap real quick, we've got sensors to feel, a brain to think, a way to communicate, and muscles to act. A complete nervous system for our motor. Pretty cool, right? Now let's see how it all comes together. Okay, the theory is great, but let's see this system in action. This is where things get really interesting. Getting this thing connected is actually way easier than you'd think. All you do is set up a mobile hotspot on your phone. The system automatically finds it and connects. Then you just open up a mobile app called Blink, and boom, you're in. And this right here perfectly illustrates the whole point. On the left, you've got this tiny LCD screen attached right to the device, showing you the live readings. On the right, you've got the mobile app showing the exact same data, but with these clean, really easy-to-read gauges. You see what the machine sees instantly. All right, now for the test. The motor is switched on, and we can see all the data streaming in. Now, using just a simple dimmer knob, the operator starts to crank up the motor's speed. And there it is. As the speed climbs, you can watch the RPM reading on both the local screen and the mobile app jump up in perfect sync, all the way to 8,500 RPM. That, my friends, is real-time visibility in action. Now, monitoring is powerful, for sure, but this is an active system. The real game changer is the ability to not just listen, but to talk back to the machine. And here's the payoff. With a single tap of a button in the app, the relay clicks, and the motor just shuts down. Tap it again, and it springs right back to life. That's full remote control from your pocket, anywhere that has an internet connection. So let's just step back from this one project for a minute. What does this all really mean? What's the bigger picture? So what are the big takeaways here? Well, first, it's about real-time visibility and control, giving people a constant pulse on their machinery. But it's also the foundation for what's called predictive maintenance. By analyzing trends, like a slow rise in temperature over a few weeks, you can fix a problem before it causes a total shutdown. And maybe most importantly, this kind of tech takes super complex industrial data and makes it simple and accessible, putting incredible insights right into the hands of the people who need them. This leaves us with a final thought to chew on. We are literally building a world where we can have a constant conversation with our machines, asking them how they're feeling and telling them what to do. The real question is, as this becomes the new normal, how is it going to fundamentally change the way we work, manage, and build our future?